In this very lesson, we shall be looking at factorials. Factorials under binomial theorem. When we talk about factorials, it refers to an operation of multiplying any natural number with all the natural numbers that are lesser or smaller than it. And I believe that at this very stage, each and every one of us knows what natural numbers are. When we talk about natural numbers, they are positive counting numbers that start from 1 up to infinity. Factorial is denoted with this very symbol. So when you have any natural number such as 2, with this symbol attached, it is read as what? 2 factorial. Similarly, when you have a natural number such as 5, with this symbol attached, it is read as what? 5 factorial. More also, if you have a natural number 7, with this symbol attached, it is read as what? 7 factorial. 2 factorial means we have to multiply the number 2 and all those natural numbers that are lesser or smaller than 2. Therefore, 2 factorial means the number 2 multiplying all the natural numbers that are lesser than it. We always end at 1 because from 1 we move to 0 and 0 is not a natural number. 5 factorial means we have to multiply the natural number 5 and all those natural numbers that are lesser than 8. 7 factorial means we have to multiply the number 7 and all the natural numbers that are smaller than 8. So we have number 5 factorial can be shortened and written as 5 times 4 times 3 factorial. We can shorten this lengthy thing and write it as this because 3 factorial will cater for all those natural numbers that are lesser than 3. This same 5 factorial can be shortened and written as 5 times 4 factorial. This is because this 4 factorial will cater for all those natural numbers that are smaller than it. So 4 factorial will be here. So it will cater for all these natural numbers. So we can shorten this and write it as that. Similarly, with 7 factorial, we can shorten it and write it as 7 times 6 factorial. This is because 6 factorial will cater for all these natural numbers that are smaller than 6. Let's take our last example on that. If you have, let's say, the natural number 10 with this very symbol, which is read as 10 factorial. So we have times 9, times 8, times 7, times 6. We can end here because 6 factorial will cater for all those natural numbers that are smaller than 6. We can still shorten this and write it as 10 times 9 times 8 factorial. We can still shorten it and write it as 10 times 9 factorial because 9 factorial will cater for all those natural numbers that are lesser than 9. Now, let's take it that you have n. N represents the natural number, and then we have this symbol. So we have n factorial, where n represents what? A natural number. So from this concept that we have given from these few examples, what do you think n factorial will be? So we are going to have n minus 1, n minus 2, n minus 3, n minus 4, and so on. So let's verify to see if it is actually right. So let's take 5 factorial, for instance. So we are going to have the number 5, which is here. Then we have 5 minus 1 is what? 4. 5 minus 2, we have 3. 5 minus 3 will give you 2. 5 minus 4 will give you 1. So n factorial means the number n, then we have n minus 1, n minus 2, n minus 3, n minus 4, n minus 5, and so on. Now this n factorial, as we were able to shorten this, we can still shorten it as that. So let's look at it. Now this same n factorial can be written as, let's shorten it. We can write it as n minus 1, n minus 2 factorial, because n minus 2 factorial will cater for all those numbers that are lesser than that. Now with this, we can still shorten it to make it smaller. So n factorial can be written as what? n minus 1 all factorial. So this and that, they mean the same thing. Now let's look at evaluating factorials. So we want to find the value for 7 factorial all over what? 5 factorial. We know that 7 factorial can be written as 7 times 6 times 5 times 4 times 3 times 2 times 1 all over. And then 5 factorial can be written as 5 times 4 times 3 times 2 times 1. So from this, we can see that 1 can cancel 1, 2 will cancel 2, 3 will cancel 3, 4 will cancel 4, 5 will cancel 5. We are left with what? 7 times 6, that gives us what? 42. Now with this same example, 7 factorial all over 5 factorial, we can write it as 7 times 6 times 5 factorial, because we are having 5 factorial here, so we can end here, and then we have our 5 factorial, so that at the end 5 factorial can cancel 5 factorial, and then we'll be left with what? 7 times 6, that gives us 42. Very, very easy and then simple. Let's take one more example. Let's take it that you are being given 10 factorial dividing, let's take 9 factorial. Now we know that 10 factorial can be written as 10 times 9 factorial. Since we are having 9 factorial here, we can end here, and then we have our 9 factorial. So that at the end, 9 factorial can cancel 9 factorial, and then we'll be left with what? 10. Very, very easy. Let's look at another example. Let's take it that you have, let's say, 3 factorial all over 2 factorial. So from what we have learned, we know that 3 factorial can be written as 3 times 2 times 1. And then we have 2 factorial can be written as 2 times 1. So from this, since they are multiplying and then they are dividing, 1 can cancel 1, 2 can cancel 2, we are left with 3, as easy as ABC. Now that we have gotten this concept, let's look at equations involving factorials. So we have our first example. If 4 factorial multiplying n factorial all over this is equal to k, we want to find the value for k. Now before we can solve this question, then we need to eliminate all those factorial from the equation. So we have factorial here and then factorial here. What must we do in order for us to eliminate this factorial? So we know that, so let's have our solution. So in the beginning, we said that n factorial can be written as n minus 1, n minus 2, n minus 3, and so on. Since we are having n minus 1 factorial here, we can end at this 0 point. so that at the end we have n factorial is equal to n minus 1 all factorial, so that this can cancel that. So we are going to have 4 factorial multiplying n minus 1 all factorial, and this is all over n minus 1 factorial 3n. This is equal to what? K. Now this can be written as what? 3n minus 1. I believe you agree with me, since they are multiplying, the position doesn't mean anything. So we can rewrite this as 3n minus 1 all factorial. So from this, you can see clearly that n minus 1 factorial can cancel n minus 1 factorial. So at the end, we are left with 4 factorial all over what? 3 is equal to k. Now the equation has become very simple. Now we know that 4 factorial can be written as what? 4 times 3 times 2 times 1 all over what? 3. And this is equal to k. Now we can see that these 3 can cancel this 3. We are left with 4 times 2 will give us what? 8. 8 times 1 will also give us what? 8. So we have our 8 is equal to k. Therefore, the value for k is what? Is 8. That is the very, very simple and then easy. Let's take our next example. So we have our second example. We have to solve this equation. But you realize that we have factorial in this particular equation. So we have to eliminate the factorial from the equation. So we have our solution. Now, we know that n factorial can be written as, now you realize that we are having n minus 2 factorial here, so therefore we can end at this very point. So therefore n factorial is given as n minus 1 n minus 2 factorial, so that at the end this n minus 2 factorial can cancel the numerator. So we have our n minus 2 all factorial is equal to, so in place of n factorial we are going to write this. And this is equal to 1 over what? 56. From this, you realize that n minus 2 factorial can cancel n minus 2 factorial. We are left with what? 1 over that. So we are left with 1 all over what? n minus 1 is equal to 1 over what? 56. So from this, we can do our cross multiplication. So we are going to have n minus 1, which is equal to what? 56. Let's expand the brackets. So we have n squared minus what? N is equal to 56. Why don't we bring the 56 to the left hand side of the equation and then see something? So we have n squared minus n. This will give us minus 56 is equal to 0. What did you see? Or what can you see? You realize that we are having what? A quadratic equation. And in finding or solving quadratic equation, we can use the method of computing the squares. You can use the factorization. You can use the almighty formula or the quadratic formula. You can also use the calculator. So let's use the factorization. So it means we are going to, for two numbers that when we multiply, we are going to get 56. And these same two numbers, when we add, we should get negative 1. And these numbers are 7 and then what? 8. So we have 7 and then minus 8. So we are going to substitute this in place of n. So we are going to have n minus what? So plus 7n minus 8n minus 56 gives us what? 0. Let's do some factorization here. So we have n is out, we are left with what? N. And then we have plus. And then we have 7 minus 8 is out, we are left with what? N. This minus is out, we are left with what? Plus. And then we have 7 is equal to what? 0. Now, since those two brackets are the same, we are just going to pick one and then we pick those outside the bracket. We put them also in a nice bracket. So we are having n minus 8 and then n plus what? 7, which is equal to what? 0. Let's continue from this side. So we have n minus what? 8. And then we have n plus what? 7. That is equal to 0. Now we know that n minus 8 is equal to 0 and n plus 7 is equal to 0. We can have our n is equal to 8 or our n is equal to negative 7. So we have two solutions. But remember that factorials is defined for only natural numbers or only positive numbers. Therefore, since this number is negative, we will be going for n is equal to 8 as easy as A, B, C, D. Let's take one more example. So we have our last example. If n plus 1 all factorial over this is equal to n squared plus np plus q, we have to find the value for p and then q. So let's write our solution. You can observe that there's a factorial in this equation. So first of all, we have to eliminate or do away with the factorial from the equation. So we have n plus 1 Now, if you can remember, in the beginning of the lesson, we said that 7 times 6 factorial can be written as what? 7 factorial. I believe you remember that. Therefore, if you have n plus 1, n factorial, we can write it as what? N plus 1 factorial. Do you agree with me? If that is the case, then in place of this, which is this one, we are going to write this. So we are having n plus 1 n factorial. And then we have n minus 1 or factorial, which is equal to n squared plus np plus what? So still, you can observe that we are still having the factorial in the equation. So you have to eliminate it. Now we know n factorial can be written as, since we are having n minus 1 factorial here, we can end here. Okay, so that then this and that will cancel. We have n plus 1 and n minus 1 factorial all over n minus 1 factorial, which is equal to. So you realize that n minus 1 factorial can cancel n minus 1 factorial. So we are left with n plus 1 multiplying what? N. And this is equal to n squared plus np plus what? Q. Let's expand the bracket. So we have n squared plus what? N is equal to n squared plus np plus what? Q. Now let's compare the left hand side and then the right hand side. So we have the left hand side and then what? The right hand side. We are going to compare the coefficients. So we can see that this is equal to that and this is also equal to that. So we have n is equal to what? Np. N will cancel this. So we have 1 is equal to what? P. Therefore, our P is equal to 1. Since you don't have any corresponding value for Q here. Our Q is equal to 0. Very, very easy and then simple. I'm going to give you some tutorial set question. Write it down. You try your hand on it. So these are tutorial set questions. See you tomorrow. Bye bye.